Okay, so now we wrote up nicely, sort of, this is how long it takes for the bus to go from the depot to here, okay? This is how long it takes for Claire to run from the farm to the same point, okay? Now, we were expecting the question to be that, like, what angle of theta would you have to pick so that Claire makes the bus on time or something, right? But it got phrased as something a little bit more tricky. But if you think about it, it's really the same. Is how long can Claire wait at the farm before leaving so that she can make the bus? Okay. I mean, the only difference is like she would have otherwise gotten here early,
Yeah.
but instead she'll get there just on time because she waited that time at the front instead. You know? So I don't know. Depending on how much time you have, right? Instead of jumping right into what you have to do, it might be good to get a bit of a feel for the question. Okay. And one way to do that is to sub in values. So in essence, you are still choosing a value of theta, okay? Because that's the only thing you have control over, okay? So you're choosing a value of theta for which Claire sort of gets to this point with the biggest advantage, you know? But to get a feel for that, maybe you can just put in some values of theta. Okay, so obviously some exact values of trig values are nice. So if those are indeed those expressions, if they're right, theta of 45 degrees would be something you might want to consider. So, for example, if it was 45 degrees, tan of 45 is 1, okay? And so if theta is 45 degrees, then tan of 45 is 1, you get 450 over 3, which is 150, right? So 150 seconds. Now, Claire takes 125 over 2 cos theta. The cos of 45 is 1 over root 2, right? 2 times 1 over root 2 is 2 over root 2, which is root 2. And 125 over root 2. Well, root 2 is about 1.4, okay? 125 over root 2, how would you do that? Maybe it's like a 250 over 2.8. It's close to, it's more than 250 over 3. So 250 over 3 is like 83, right? So maybe it's like 85 or 90, yeah? So let's say about 85. Of course, you could just do it on your calculator as well. And then, so Claire would get to the point, like about 60 seconds, 65 seconds faster than the bus. So Claire could just wait 65 seconds and then leave, right? So then Claire would leave at 8:01, right? Okay. So if you're happy with that, you could probably just get to the solution, but you could also do more exact values. So another exact value would be nice, I think, is 60 degrees, because cosine of 60 degrees is 1/2, right? So that would mean cosine of is a half times 2 is 1, and then c would just be 125, right? Tan of 60 is root 3, okay? And root 3 is about 1.7, okay? So 1.7 times 50, well, that's like 170 divided by 2, so it's like 85. 485, so it's about 485 divided by 3, right? Which is like 160 something. Let's just say 160. So now you can see the difference is a bit less, right? It's 35 seconds. Okay, maybe you could look at, and this also gives you a good check for your answer at the end, because if your answer is like, like a really long amount of time, it kind of disagrees with these data points, right? We're kind of expecting the answer to be of the order of minutes, okay? Probably less than 10 minutes. Okay, so 30 degrees is a bit harder because it's a surd for cosine. So cosine of 30 is root 3 over 2 times 2 is just root 3, okay? So 125 divided by root 3, it's going to be like, what's that? 135 divided by root 3. 125 divided by root 3. So it's going to be less than 80. Okay. Maybe it's going to be around 80. Let's say it's around 80. Okay, it won't be too far off 80, hopefully. And then B, tan of 30 degrees, 1 on root 3, 50 over 1.7, that's going to be like, like 100 over 3.4. So it's going to be like 30-ish. Then it'll be like 430 divided by 3. Okay, so 420 divided by 6 is 70. So 430 divided by 3 should be close to like a bit more than 140. Okay. Yeah, these are very approximate now, but to give you an idea, this will give you like a 60 seconds. So it'll be less even. So it's not just make the angle as small as possible. Unless I made some mistake, but then it'll give you an idea that the answer might be close to a few minutes. Okay. Now, what is the actual problem? Well, you're trying to get basically to P earlier than the bus. Okay. And however much you get early, you can plan for it and then just wait at home, right? Yeah. So the actual question is to maximize B minus C, right? So the B minus C is how much time that you have over the bus. And you want to maximize it for theta. Makes sense? So you want to pick a value of theta so that the expression B minus, so that this minus that is maximum. Because that expression tells you how much time you can wait. Okay? So at this point, the problem is completely routine. Okay? Because in the course, you're actually taught exactly how to maximize these expressions for theta. And it's a simple exercise in calculus. Okay? So that doesn't actually, the time it takes to do that is sort of fixed in a way, because kind of everyone will do it the same way. Whereas to figure out that that's the mathematical problem, that's kind of a little bit more open-ended, and now we've kind of, like we're relieved that we got here now.